that when was introduced in what the attacker could do had a very significant impact on the dropout of the data. Why? Because that allowed the attacker to control many paths. We could perform other attacks and maybe show like how much data goes through that particular node that later on could have been used for traffic analysis. The other thing that we showed in this, which was, as I said, was quite for us was, as I said, from the attacker point of view is good, but from the point of view of people that designed the protocol, for us was a big alarm when we saw that having only 2 colluding adversaries. So as an adversary, you had to compromise 2 nodes. It's true you cared about their position. And just having all those you could reduce AODV delivery ratio to 50%, 51%, which means that half of your data never makes it. And as I said, coming from the distributed system community where the reliability and availability are extremely important, this was something that we weren't very happy with. And in general, most of the attacks we could mitigate, but there are the protocol is not a cheap one. I'm not gonna lie saying that it's very cheap. It has additional overhead. Some of it is just from the fact that you have to process more flood requests in order to avoid the flood rushing attack. That's why ODSBR actually reacted very well to that, and we didn't drop that much traffic. I want to use the last minutes to tell you a little bit. It's still 11:20. Okay, so I'm going to use 10 minutes just to show you how some of these ideas, you can take them and apply them in another environment. And it actually turns out that in the environment that we moved, it was much easier to address some of the problems. So what is this environment? Well, this environment, it's an environment that has a 3G wireless network and also has a multi-hop component. Then now, why do we need the multi-hop component? Well, the promise of the 3G cellular networks were that you could do data, you could do video, you could do images. So you have all these applications that are pretty nice. In such an environment, how does it work? You have a base station, you have a user, there is a direct connection, wireless, of course, between the base station and the user. The user gets authenticated by the base station. That's how the traffic goes through. So it's an environment that is centralized in some sense because of the presence of the base station. Now, the further you go from the base station, the quality of your traffic, the quality of the data, and the throughput that you can get is much lower. So one group from UCLA suggested that you can actually go around this problem by having a wireless LAN, a multi-hop network that was playing AO211, which is the wireless, you have the wireless LAN created there, such that when you get too far away from the base station, you can get good traffic, like high bandwidth, just by using the wireless. This can be laptops, for example, and they are using a different type of technology that allows you to get a higher bandwidth. So that was pretty much the idea. And this was proposed, as I said, by a group from UCLA. Now, Bogdan and Yanis came to me and said, look, we think that we can do better than they do. And I said, well, I don't believe, let's see, let's talk. So they showed me they had the protocol that their goal was to get better throughput. And they had a very nice distributed protocol that allowed them, they were building some trees using, they were also using some algorithms that allowed them to have everything very low overhead, decentralized. So everything was nice and I like it, but I asked them, well, you realize that the moment you put the multi-hop component there, your trust model changed. Why? Well, because as long as you had only the relation with the base station, which anyway, if the base station wasn't there, there was no service, it was one type of trust. The moment your data goes through the intermediate hops, from the security point of view, things change. Because you cannot have the same type of trust. So these intermediate hops actually, they're supposed to be users. So these are not dedicated, this is not dedicated infrastructure, at least in the model that was proposed by them. So if they are users, why should you trust them? So that's pretty much how this work started. Then we said, okay, let's look from the security point of view, what happens, what are the implications that we have these relayers here? So how can we look at it from the throughput point of view, because that was the goal of the application. And security is always something that, it's an extra. Whatever service you have there, you'd like to protect that service or that information or that data. So we look at what are the type of attacks that can happen. And besides the ones that we knew about, here in this case, the things that we cared about is how do you decide which is the best rate? Well, it's because nodes usually report. So the way the protocol works, you build a tree, and the tree maintains the residual capacity in the network. That's how you know what is the next best throughput path that you can have there. Well, but how is that built? Nodes are telling how much rate, what is their rate from where they are positioned to the base station, and there are all kinds of implications by the fact that you rely on information that comes from these guys. Well, they can lie about that information. They can lie about their position. So what can we do about it? So these are the bad news. What are the good news? Well, the good news was that the base station was still there. So, and not only that the base station was still there, but the wireless communication, the cellular link between the base station and each user in the network, it's still there, and we could use it as a control channel, kind of. So you use the purpose of the original system without security is that, you know, depending on how far away or close you are to the base station, you are using either the multi-hop or the cellular link. And then when we looked at security, we say, you know what? I like very much the fact that the cellular link is a direct link between the base station and the user. That's a link that can be trusted. So that turned out that it helped tremendously when designing the protocol. So we looked both of how can we prevent people from inflating the rate that they are reporting, and we also look at how can we prevent with respect to data that goes through intermediate hops. The same, one of the things that was in common with the previous protocol, can they drop data? How can we prevent? How can we detect that? There were two things that help us better in this case. Let me go to, so first of all, the overview. So we have a secure routing path maintenance, which basically we maintain this tree. Then we have a secure path reservation because the user requests a particular type of service. This is the amount of data, and this is the commitment that we are making. And the last part that we cared about is how do we do the data forwarding. From the perspective of the previous protocol that I presented, what is interesting and I would like to spend time on is the last aspect, secure data forwarding. Not that the others are not important, they're actually quite difficult to achieve, but I want to talk about that just because it is, it shows you how the environment can make a problem easier or more difficult. In this case, it makes it much easier. Why? So how did it work before? Remember, I was doing the search on I have the path, and I was breaking the path, and all the probes were going through the multi-hop, and all the acknowledgement were going through the multi-hop, and all the errors were going through the multi-hop, which means that you have to protect the mechanism itself again. So because the nodes in between could affect or could try to attack this probing mechanism or the error reporting mechanism. In this case, I don't need to deal with that. If I take advantage of this direct communication between the base station and the individual node, I don't need to go through the whole, making the probes look like random data to prevent them from being dropped, making the acknowledgement, because we had all kinds of sophisticated mechanisms to deal with this. So, for example, acknowledgement, you don't send only one, you try to, wait for some of them, try to put them together or try to piggyback them on data and so on. So in this case, we don't have to deal with that. All that it stays is the same breaking on the path, but the request of who should, that's another thing. How do I ask as a source, when I break the path, I should ask nodes to report. And I said, you report and you report and you report. This packet goes through each hop. So when this happens, you open the door for intermediate nodes to start blacklisting. So you get into all kinds of trouble, and to get around them, as I said, you take advantage of cryptographic mechanisms, but the cost is pretty high. In this case, I don't need to do that. So this is just an example where actually by moving in a different environment, taking the same idea, it turned out that it was much better in terms of the overhead. So this protocol, we didn't implement it yet. We are in the process of implementing it, and we will see how it behaves. There are many things that we still have to deal with, and one of them is the verifying